Okay. There we go. Hello everyone. Let's see if we can. There we go. Hello everyone. Hi. We will continue today on a project we started yesterday. So welcome back. It is a little bit earlier today than it was yesterday. It's still very late in Europe, I know, I'm sorry. Yeah, we are back and we will continue the project from yesterday where we were assembling the FTDI Multitool adapters. I'm just checking that all the streams are running. I think Twitch is okay. YouTube seems to be fine too, as far as I can tell. So yeah. Where were we? We were assembling these FTDI Multitool adapters or boards that I designed a week and a half or something ago. I was explaining yesterday that the motivation for this project was programming the ICE40 FPGAs, and the fact that the breakout boards that I found so far, or the FTDI cables, either don't have MPSSE support, which is necessary to use the open source IceStorm programmer, or the boards are I figured it out actually overnight. Is the boards that are designed usually with the FTDI chips as breakout boards have the two-row connectors, I assume, for breadboards. So that probably explains why they have this odd two-row connectivity usually. So these boards are a little bit different. They have the pin header connector on the front of the board, and they connect into the breakout boards that can adapt it to different applications, including the icebreaker BITSI that I designed, as well as just a normal 20-pin breakout for whatever application you are using it for, and a bunch of PMOD adapters to connect it to your FPGA project, as well as a JTAG programmer adapter. Today I wanted to continue on the yesterday's stream that I had to stop early, where I finished putting solder on it. I put it in the reflow oven, I reflowed the boards, and now I pulled it out of the oven, and I found out that there are a few tiny shorts. We will clean those up, and then after that is done, we will put some connectors on it, or maybe even just first plug it into the computer and see if it enumerates as a USB device, and then we will move forward from there, hopefully validating that it hopefully works. We will see, and if it does, then we can move forward and send them to a few folks and get going. All right, so let me see if my microscope is actually working. There it is. So here is the board. Let's see if the focus is right. So we had an issue. So I looked at the QFN, and so far so good. I don't see any shorts on the QFN itself. That worked out well. Yep. And this flash chip with the SOT236 seems fine too. And oh yeah, we had some that had the USB connector issue. I think we will use the heat gun to fix this. It's easier than doing it with the soldering iron. And we had some shorts on the on the resistor array here in the corner. So we will clean that up. Let me zoom in here. Yeah, there we go. Is that visible? Yes. So yeah, I heated up my soldering iron already. Let's see if we can just clean this up with this soldering iron quickly. And get the, yeah, as I said yesterday, I feel I have to improve the footprint of the resistor arrays because I'm getting that problem quite regularly, even on the Blackmagic probes. That has 2 of these resistor arrays on the output pins, and yeah, we are getting, and oh yeah, and for the LEDs, I think the LED current control resistors are in there too. Let me do one more thing here. Oh, hi Micah, hi Scanlime, you are now on YouTube. Nice to see you there too. Thank you for joining. I was curious if anyone is actually watching, because I don't see the numbers here. Yeah, so this side is not that critical of the resistor because this is all connected to 3.3 volts. It's a pull-up. So these are four pull-ups in one package. So this is not really a problem, but it is annoying. I want to have it nice and clean. Yeah, I should probably heat it up. Yeah, some people are saying I should get myself a preheating station. So this is like a heater that heats the PCB from the back and allows to bring up the whole board to a easier temperature to deal with and rework. Yeah. Okay, I think we're good here now. I might have... Okay, let's see. This is... Yeah, this seems to be clean. Yep, okay, so that one is fixed. Let me quickly inspect the rest. It looks good, good, good. All right, that's one. The 2 others I think have more issues, like for example, here between the differential pair we have a short, and we have a short on the pull-up resistor. So let me zoom out a little bit. There we go. Hey James, yes, thank you for joining. Yeah, oh, and Dean, nice to see you too. So yeah, that's why I'm streaming on Twitch and YouTube, because I know that for some people YouTube works better and for others Twitch works better, so you should be able to find the stream on either. So we have 2 backup sources for the stream, so that should be good. Okay, let me just move this like this, maybe better. Yay! Thank you, Micah, for sending the folks over here. It's a nice troop. I like it. Okay, so yeah, some cleanup today, and hopefully finishing the bring up of this FTDI project. And maybe we can even try to program a icebreaker Bitsy board with it. That's at least the plan for now. But yeah, we will see how things go. I don't have enough Verilog examples that I can play with at the moment to try out the PMOD adapters. And my Verilog Voodoo is probably not good enough to do that on stream, but we will see how things go, how much time this all takes. Yeah, and as I said yesterday, we have too much solder on here. Let me add some flux on this as well, should make things a bit easier. This is really crusty by now, so let's clean this up. Let's get the tissue. There we go. Tacky Chip Quicks flux, yeah. There we go. And let's put some in here. Let's make a mess. We'll make it easier. Come on. Yeah. Yep, there we go. You don't need much, just a little bit. This will help the solder to flow a little bit better. Come on, it's tight in here. Soldering iron has very little wiggle room. Let's get more off. Come on, you can do it. Yeah, I should probably just heat it up, not be lazy. Let's get the rework station heated up to proper temperature. 250 is good. There we go, and I need some insulation because this sinks heat. So let's put it on a different PCB. Do we have some? What do we have here? Let's put it on top of this. There we go. Should make things easier. There we go. And if I heat it up and use my tweezers, I should be able to get rid of that. That's short, but it takes a little bit of time to heat up everything. The previous board, it worked easier for some reason, and this one is a little bit more stubborn. Hijack F486 embedded motherboard from the DIMM slot too. No, I leave that job to Micah, I think. Because she was saying she will be doing that, as far as I understand. I was not exactly following the developments on Micah's channel in the recent few days. I only vaguely heard about this story, about DIMM. So I need to... She needs some hardware for it. Can talk about that. There we go. Yeah, it's still not being cooperative here. There we go. Now it plopped. Good. So now let's see what we can do with this guy. This has to be held. This is not good. I should clamp it into my stick vise. This will be more easier to control because this is too floaty. Yeah, I have the upgraded Teflon jaws for my stick vise, making it very nice for this kind of use. I still need to put something underneath to protect my mat, because the heat from the heat gun will will melt my table. I don't like that. So let's see. We want to adjust this. Yeah, focus, focus, focus. There we go. That's important. Let's zoom out a little bit. Yeah, I will pretty much just heat it up a little bit and then move the connector around to get rid of the short, and that's pretty much it. Okay, so let's see. Should probably add some flux here too to make it flow better. Just a little bit here. Okay. Come on. There we go. It's starting to flow. There we go. Just move it a little bit and see. Okay, can access. Come on. See the short. Probably should just pick it up. There we go. Reflow the whole thing. Put it back on. Yeah, remove the short here. Okay, let's do that this way. Remove the short from the pins here. Come on. Yeah, there's excess of solder on here. Okay. Yeah, this is caused by the stencil not being flush. I think that I should improve on that. So the approach from Bob was probably the right one, of using other PCBs to create the same level for the border. I should have done that. I didn't. That was a mistake. I admit it. Okay, so there we go. Let's heat it up again. It's the wrong way around. Let's put it back on there. There we go. And kluk, kluk. Come on, you can do it. The ground pad is being a jerk here. There we go. Does this look good? Okay, let me inspect this. There we go. It looks definitely better. So do you see this? Yeah, we had a short here. Now we don't. That was the goal of it. Took a little bit, but we fixed it. Then we fixed the resistor. That's good too. Okay. So that board is fixed now too. Now 3. This one has the same set of issues as the previous one. One is the resistor. Let's put some flux on here, just a little bit. And then, oh, no, actually this doesn't have a short. I thought this had a short too. Did I misplace the board that I was working on? No, I didn't, because this had a short. So the USB short was the only one. But we still should probably move it, because this one is moved way into the board. So I will still move it. Yeah, while I'm already in here. Let's add some flux. This is, I think, no clean anyways. Does it say? Yeah, no clean. Tuck flux. So don't really have to clean it, which is good. Makes things easier. Yeah, this was the best thing that I found. So I had those flux pencils in the past, and they never really were useful for me because the flux always evaporated so quickly, was pretty much useless. Until I learned there is this other type of flux called tacky flux, and this comes in the syringes. And it's very tacky and it stays around, making soldering much easier because it keeps working even if you are trying to spend some time reworking a board. So yeah, that was a really good find. I actually learned that from the people that are fixing iPhones and MacBooks and stuff. I did not know about that until then. Okay, so that one is adjusted a little bit. There we go. Why is no clean the worst? I think it's the best. So Daniel Egger, welcome to the chat, and yeah, welcome. I don't know why you're saying that no clean is the worst. I really like it. It's like all my flux is no clean because it makes my life so much easier. Using rosin flux means you have to clean the board, because otherwise you get shorts on the board because it is conductive after it's being used. So not having that issue anymore was one of the best things since sliced bread for me. Yeah, it is getting too sticky over time, sure, but I don't know, it works for me the way it is. Okay, I think we have this fixed. Yeah, that too, yeah, rosin flux causes corrosion over time. Yeah, I'm not a fan of rosin flux. I had really bad experiences with it over time. Especially putting together a prototype of something, then plugging it in and seeing it go up in flames because I did not know that I have to really, really thoroughly clean it. Even if you clean it properly or try to clean it properly, the residue can be conductive and corrosive. And doing a really good cleaning job on this it was always very hard for me. I never found a good way of doing that. So yeah, I'm still cleaning it here, see? So because there was an excess of the tacky flux. The problem is it leaves this like little bit of a gray residue even after cleaning. So yeah, there we go. Should be good enough. There we go. So that's adjusted. That's moved. Yeah, there we go. Okay, so I think we should plug it in. Let's see. There we go. Let me switch to a terminal. LS USB. Oh, it has uses if you have exposed copper. Okay, I can imagine that there are situations where rosin flux is the best. Okay, so I don't think there is a FTDI device currently connected to my computer, so let's plug in a USB connector. I did not put any LEDs on this board. I did not think it is really necessary, so plug in, and there we go. Future Electronics Ltd. Future Technology Devices International FT232H. Here we go. So 1, then let's see if we should be gone again. Number 2. Yes, it's there, perfect. Again, should be gone. There we go, perfect. Okay, so we have 3 FTDI boards that are enumerating, so that's a good start. Now, let's put connectors on them. So the connectors, don't know if I'm pressing the right button. Tab, there we go. So let's zoom out. So this is the connector I will be putting on there. It's a female connector, and on the adapter boards we will put male connectors on. I don't think I have enough of them as far as I can tell, because I ordered 10 and we have 6 different adapter boards, but yeah. Yeah, I did use Löt Honig in the past at my old job in Germany. So I know what it is. It's incredibly messy, but it works really well. That's true. So yeah, Löt Honig. It does smell nice too. Yeah, that's true. Okay, so let's see. How do I keep it in place so that it is nice? I should probably just tack it down. I have one pad, then tack it down, and then we can solder it in. There we go. So let's soldering iron, some solder. Yeah, I do it on the other side, so on the, not the ground pad. It should make it easier to handle. Should probably use the bigger tip. That will be easier. Let me change the tip on the soldering iron. Is it up to temperature? Yes, good. There we go. Very good. Now I need to adjust it. I love the JBC quick change for the tips. That's so awesome. It heats up so fast. So yeah, I think this is straight. There we go. So it's close enough. Let's do another pad. There we go. Come on. There we go. Yeah. Yeah, I could use paste on this, that's true. I don't know what the right solution is yet on this kind of edge pads. I'm thinking actually that I will switch over from this SMD solution to something easier to do, but we will talk about that after I'm done with this. I have some connectors that are through-hole for this pitch. The problem is that half-pitch connections, the pads that I have so far, would not have enough clearance to route a trace between the pads on either side of the PCB. So I need to adjust the footprint a little bit to make it easier to use. So yeah. It's also a bigger problem here on the female connectors, to be honest, because they are flat and there is more clearance between the PCB. For the male connectors, it's easier because they are fitting much more snugly onto the PCB. So it's not as much of an issue. Yeah, it's not fully straight, I know. Yeah, this side is easier because it's already placed down. There we go. Very good. That's the first connector. Yeah. So as you see, I also added solder pads on the back for the USB connection so that you can wire it in, like hardwire something in if you want to, or solder in a wire directly to the board. Some people might want to do that, or for debugging purposes, if you actually want to see the USB protocol and trace it or something. So yeah, that's looking good. There we go. Will that work? Come on. Yeah, the webcam is completely unable to do any focusing. It's really weird. I wish it was a little bit better. Yeah, all right. So let's move on to the next board. Let's do 2 more. I need connectors first. Jesus. Okay. Yeah, I have to place an order with DigiKey or someone. So anyway, I wanted to also mention that the alternative would be to use these through-hole connectors. So I ordered these. Like, this is a full array. If you look under the microscope, it's a right angle version of it, so I could theoretically just solder it in into the PCB. And the problem was to get between the pads here. So I have to look into the footprint and maybe slim them down, make them oval, the pads, so that it doesn't have so much meat on the side. So you can get with a 0.15 millimeter trace between the pads, or maybe even go to higher density design and make it smaller. So that's something to look into. Or use SMD versions of those connectors, but then they need some alignment pins. Then they have to be already pre-cut into the right size. So yeah, that's a problem. Okay, let's try the same thing we did with the previous one. Add a blob of solder here. Maybe we should add blobs of solder on both sides so that it is fitting more snugly from the get-go. Let's see how that works. Come on. And there's it. Okay, like this. There we go. Straight? Is it straight? Something like that. Yeah, so this is... And now, if I... Oh yeah, so I will solder one of the exposed ones first. One, and two. There we go. That makes it easy. Come on, you can do it. Come on, pad. It works actually easier than I thought. So basically adding some solder on the edge pads, then slipping it on so that it stays in place, and then soldering it down makes it very easy. I'm surprised. Well, not surprised, it's a good solution. There we go. That's one side. Is it straight? It's straight. The second side. Huh, it's offset, that's weird. It looked very much on center on top. Huh. There we go. Good. The lag, it's like 90 seconds. So it depends, I think, on where you are. So yeah, I would assume that the lag is very long to Germany, because it might be buffering more. And also you can try to compare Twitch versus YouTube chats. And there might be a big difference between one and the other regarding how much lag there is. I did set YouTube to have the, I'm running it with the low latency setting. I think. I would have to check, but I'm pretty sure I did set that. So it depends on how YouTube is routing it and what your exit point from their network is. Because as you might know, if you're watching YouTube, you're actually not watching from a server in the US. They use an internal network to get into an exit point near your ISP. At least that's what I heard. Yeah, so maybe we do adjustment here so that we know it is very much on center. And check on top how it looks. This is so strange. There. Is that straight now? Is that straight now? Yeah, it is straight. Ish. Want it perfect. This is the last one. There we go. It's so weird. Like one side of the pin seems to be a little bit different than the other. Okay. Well, it has to be good enough, I guess. That is straight. That's not. Okay, well, it is what it is. Get the chat marked. Okay, there we go. Let's move this into the screen. There we go. And the center, yeah. Come on. There we go. Yeah. Okay, one side. Now let's do the other side. The solder blob is messing with my vision. Yeah, I have a solder blob in my eye. Yeah. It looks straight on one side and then on the other it doesn't. So yeah, there has to be some... Yeah, it is not straight here. Yeah. Whatever. This is not a great solution, obviously. Lesson learned. So yeah, if the edge of the PCB was a little bit longer, I guess, then we could just push the connector against the edge. I should have probably done that. Just push it against the edge. Yeah, oh well. It's done now. It's not perfect. Yeah. Yeah, okay, it has to be good enough, I guess. It annoys me a little bit now, but okay. So what we wanted to do is to put together one of the Icebreaker Bitsy programmer boards. So that's what we will do. So we need a connector. This is this one. And this one should probably just fit on there. Just press it on. Yeah, this one is much more snug. Much more snug, because these are square pins. And now, even without soldering, I can already test it out here. Very nice. That's very cool. Okay. Let me solder it on. Yeah, these are easy. The pin headers. Because they're very well connected to the pad, so the heat also transfers nicely. So yeah, that's very easy. So this side is not a problem. It's more annoying the other side of the connection. So I might try to figure something out for the main boards and keep these like that as a kit. And there we go. Okay, so that's the yeah, there we go. Oh, there we go. So yeah, let's just plug it in, plug it out. And you get a nice adapter. And it's quite good and snug in there. So yeah. So now we need the pins to do the programming. So what I will do is take some of the male headers, break them to size, solder them in, and then because this is a pattern and it's offset because the ground is here offset, so this should fit on the other board like this. So I will do that and then put in some male headers in there so that I can program a board that has headers already in there or not. So let's try that. What is the width I need? I need 6 pins first. So let me get 6 pins. 1, 2, 3, 4, 5, 6. And crack. 1, 2, 3, 4, 5, 6. The next one is destroyed. Is this correct? I should compare this. Ground, chip select, clock, data. Yes, that looks good. Looks good. And I need an X-Acto knife to clean this up. Let's clean up the edge here so that it is nice and flush. Not that it matters too much. I think this is the X-Acto knife I used for cleaning up the PCBs. It's quite dull now. But it still works on this plastic. Yeah, okay, good enough. Oh, I could, oh, good idea. I have an idea. I have a 1-bitsy here. And I can align the pin headers accordingly here. And then I can put also this singular one on here. I should have put the one hole in the side here to make it easier. Yeah, this adapter probably needs more work because there's only one staggered pin. I need a better solution for this, for the programming, because moving the ground here is probably not a good solution. But having a 2-row connector that just plugs in onto dummy connections here might be a better solution. Yeah, I think I know how to do this. So the problem is, if we look under the microscope here, where is it? There. So the pins are not aligned. So the ground pin is not here because the 1-bit-C, the ground is also in the corner. If you look here, the ground is here. So I didn't want to make it the icebreaker bit-C incompatible from the 1-bit-C board. So I have the programming pins on the edge here, and then I have it staggered by 1. But if I do a 2-row connector that has 7 pins, 7-pin 2-row connector, and just use the ground here, I think that should be fine. Yeah, because you cannot really access those pins anyways when the adapter is on the board. That's a solution. So I know what to do with this this adapter. It has to be a 2-row 7-pin connector with the correct pinout. Let me close the door. Okay. So in this case, this exception, we will need to sacrifice a singular pin here. And then let's clean this up. There we go. So if I plug this in here, there, and then plug in this here, yep, it's staggered. Now I plug in, there we go. All right. That does the job. Is it somewhat straight here? Yep. So what I did also on this adapter, which I can show you in a minute, is I have the option for connecting either the way, so, okay, let me rewind. The icebreaker or the ICE40 programming interface over MPSSC FTDI interface, the dev boards that Lattice is selling, they are connecting the MPSSC lines in a very weird way. It's not a standard pinout. They have one of the GPIOs connected to the chip select line and not the dedicated MPSSE chip select line, resulting in a different pinout. You have to actuate the chip select line by hand, and it's not a standard SPI interface, because that's all it pretty much is. When you are programming over MPSSE, you are accessing the flash, the configuration flash or the bitstream flash over SPI, because that's what the ICE40 chips are using to communicate or to load the bitstream in. So there we go. Is that too short? Let's do it this way. So I have a pin header here, and let's break it off and make it like this, something like that. There we go. Okay, so that should be good enough. Let's take the icebreaker board. I need a second USB, and then we can try it out. I need a second USB cable. Do I have a second USB cable I can use? That's mini. I need micro USB, please. Micro USB. That should work, yes. So, let's go here. Let's go to not hardware, but let's go to Ice Storm examples, and then we have icebreaker, and then we can do make. Oh, it's already made. Can the make file actually upload directly? Yes. Make flash. What is the make prog? Okay. Although, is that, no, it's just prog. Make prog. This will of course not work because the FTDI chip is not there. So now I take one of the boards, I plug in the adapter, into the board, and I need, this is not long enough, should have a longer board. Let's see, here on the table. So this is the adapter board now, has this weird setup. Will this actually adjust focus ever? Yes, well, once. God. Okay, there we go, and then we connect this guy. So currently it is running the tiny FPGA bootloader, but I will just upload a bitstream over here. So let's plug this in like this. Let's just squeeze it. Aha! It is programming. Yeah, there we go. Yeah, I don't have the additional pins connected, so they are floating around like crazy. Yeah, so this Verilog is for the big icebreaker board, and it is it has additional buttons that have a defined state, and so me just putting that bitstream on there causes this thing to be a little bit wanky. But yeah, it definitely shows that it is blinking here, and if I go into the terminal and do the upload again, let's do it again, let's just tilt it a little bit and then go and prog, and it is definitely doing it. Reading, verify, okay, perfect, very good. Okay, so first adapter is working, very good. Yeah, we can assemble more of the adapters if we want, but I think what I will do is show you a little bit of the design of the board first while we're already here. So this is the FTDI board. It is just USB connector, FTDI stuff, the flash that I have to figure out what exactly I want to put in there, which vendor ID and stuff, so that it works with everything we want. We probably, so this is a 2-layer board. It's not a 4-layer board because it's so simple. And then we have the 20-pin connector on here. Yeah, so nothing too complicated. This design of the board, I can actually make, let's do this and go to GitHub. So the design of these boards is on the Icebreaker website, I mean GitHub page, and it's in hardware, and then here's the FTDI board, and then there's a bunch of adapters here, and we can assemble those and test them, but there's nothing much I can do with them for now. I think I will just assemble one each for now and see if we can figure out some firmware, I mean some bitstream for a board to play with it at some point. What I can do, that's actually not a bad idea. I can also populate one of the JTAG ones and try OpenOCD and see if that will work with OpenOCD too, because it should. There shouldn't be a problem with that. Yeah. So we have this, and now I have to figure out how many boards I can assemble, because there is, for each one of those sets, we have 1, 2, 3, 4, 5, yes, 6 adapters, so we need 6 of the pin headers per board, so 6 times 6 is 36, so I need 36 of those connectors, and I only have 10. So I definitely need to place an order for more of those pin headers. I've seen them on eBay for pretty cheap, but I don't have the straight ones, and usually eBay takes a very long time until they're here, and I wanted to send that stuff off. So, but what we can definitely do is, yeah, I can assemble the other pin headers on all these boards and test it out. But yeah, I think that is pretty much it for now. I promised yesterday that I will do a few updates on the other projects we were making. So I wanted to show you what we were working on with Bob and a few other folks like James Hagerman and Micah. You might know that I was working on the 1-bit C1 up, which is this wonderful device. This is inspired by the Game Boy. It's a retro-inspired game console that we are working on. I made this as a badge for last year's DEF CON. There were several things we wanted to improve on this device, and there will be a new revision. I already started on the schematic for it. One of the issues that I ran into was my audio circuit, because I have no clue what I'm doing, was pretty bad. I had a digital, so the premise was to use the internal DAC of the 1-bit C. So this is an STM32F4 with dual DAC outputs. The typical thing what people do is use a dedicated audio DAC over I2S to do audio. But there are already 2 DAC outputs on the STM32, a 12-bit DAC. They are not great, but they are there, so let's use them. The question was, so what I did is connect an amplifier for headphones to that. While I was looking for options for potentiometers to do a volume adjustment, it turned out that the volume knobs that I wanted to use, so the dual wiper potentiometers that Panasonic was making that are right angle, they were discontinued and Panasonic stopped making them. meaning I didn't want to design in a part that will be difficult to get. So what I did instead, I put a dual digital potentiometer on here, so you can control it from the microcontroller over I2C, and then put some volume buttons. But this design turned out to create a huge amount of skew on the audio signal, and it just sounded horrible. And I did a bunch of adjustments here. I can show you. Yeah, so there's a lot of budge wires on here, including the fact that I ripped off the audio jack at some point. So there was some reworking happening here. I spliced in some capacitors in line to decouple the audio jack, trying to fix things. So I had to like scrape off traces and solder in stuff, and then I did some biasing over here. Anyways, at the end it turned out it all was just not working. So thanks, Jim. Welcome to the chat. So Bob Miller was amazing, and he figured out together with some other guys, and I think Micah also pitched in, and based on that recommendation we found an amplifier that has 2 speaker outputs and 2 headphone outputs in one amplifier chip. And this guy here, let's see if we can show this off. Yeah, that's the guy. He made this after this fix board, this audio fix board for the 1BitC, with a really beautiful audio jack with a clear top. So if you plug in headphones in this, where are the headphones? I had them somewhere. Okay, let's use these. There we go. If you plug it in, you see the donk. I love that connector. That's a great connector. It's like you see it plug in there. Woohoo! I like transparent cases. Then it has a potentiometer to adjust volume. It has automatic detection of the audio jack being plugged in, and 2 speaker outputs that I don't have hooked up at the moment. So based on that, this audio seems to be working fine. I can power it on, but looks expensive, the connector. It's like, in this project, price doesn't matter, in my opinion. It's like, this is I want it to be really cool as far as possible, and we will eventually look into how expensive it all becomes, but no, we are not using a digital potentiometer, so it's actually more complicated. So Jimmy T is asking if we are still using a digital potentiometer. So the answer is no, but the voltage divider that we are using, this potentiometer, that is an analog potentiometer now on, is connected to the amplifier, and the amplifier is taking that analog value and has 16 steps of volume that it is then stepping the output with, which is, so it is converting from analog to digital and then from digital. I think this is like some comparator stuff that is in there to switch in different attenuators. That's my assumption, but someone would have to decap that thing to see how it is built. So yeah, yeah, it's an analog potentiometer, so there's more. Yeah, it goes up to 16. Yeah, it's like up to 12, 11 is not enough in this case. It's up to 16. It's very loud. I cannot crank it up very much. But what we can do is put in a battery. So as these are beautiful 18650s. And we plug it into the back here. Yeah, so plus minus. I like those metal holders that we found on DigiKey. So plonk, then switches on. So there is a demo. You might be familiar with that. I think I showed it on the Kickstarter when we were doing the 1Bitsy Kickstarter. We were using that video demo back then. So I can switch an app over here. And then we have a very simple game engine that I wrote. It's like, what is going on here? Oh yeah, there we go. So you can move the sprite around. I don't think it's an IPS screen. It's one of the screens from ByDisplay. It's a 320 by 240 ILI control display. And I wish I could find an affordable ILI driver with an ILI chipset, really high quality IPS screen. This is, I think, just a TFT. With this nice big pixels, 320 by 240, nice IPS screen. If you know of any that use the 50-pin ribbon cable connector, let me know. I would love to try it out. If you look in the right upper corner, this is the gamepad bit stream coming out. So that's the yeah. So some people are starting to find. So regarding Robert Eli is saying that they also frequent ByDisplay, and an IPS display would be great. Yeah, I totally agree. And the solution these days, some people are looking into using just cell phone displays and use the MIPI DSI interface. You can emulate that with the ICE40 chip, this interface, even though it's proprietary. Some of the STM32s have that built in, and some other are microcontrollers. But yeah, so that's the game that we are working on, that I was working on, and then we are in this test mode that is outputting a sawtooth wave. So I can plug in the headphones. Let's see how horrible that will sound. If you adjust volume here, you can. So the microcontroller can sense the volume that you're setting with the potentiometer. So we are at least being able to do that. So by default, it is seeing its normal speaker, if you see here. And now when I plug it in, it should detect. And it says also normal headphones. Zoom, zoom, zoom. Come on, you can do it. Ah, so annoying. There we go. There we go. Normal headphones. So now, there we go. You hear this? So it is buzzing, the sawtooth. I think there are two frequencies that are coming out. But yeah, we are working on some audio software for this to actually be able to show it off. And this is totally on the bottom. This potentiometer goes from the very bottom to very top, and this is how loud it already is, being completely at the bottom. So this amplifier has a punch. Yeah. Yeah. It's very, very damn loud. So be careful, kids. Yeah, so that's one of the projects I'm working on, and I promise to give you a short update and some info about this project. So yeah, let me know if you have any questions. Yeah, the startup sequences. So Ryan Pavlik is mentioning that the cell phone displays need a datasheet or an app note that is describing the startup sequence and the commands for the display. Otherwise, MIPI-DSI is not terrible. I agree with that, at least based on cursory research and what Mike's Electric stuff. If you go on his channel, he reverse engineered the MIPI-DSI interface for the what was it? This was an iPod Nano, I think. And he was building an installation, and he implemented MIPI-DSI using the ICE40, ICE40 or the Max something. One of the FPGAs, small FPGAs, he implemented MIPI-DSI, even though it didn't have differential drivers, which you'd theoretically need for MIPI-DSI because it has like a single-ended mode and a differential mode that it is switching between, depending on if it is doing configuration phase or pixel phase. So yeah, it's an interesting protocol. Oh yeah, okay, that's good to know. Yeah, so if we decide to go with MIPI-DSI stuff, I will definitely have to pick your brain. So Jimmy T, Jimmy T is asking about the digital potentiometers. The problem with the digital potentiometer in this particular application was that I was taking audio output that was DC biased above ground and then going through DC block capacitors to the digital potentiometer. This caused the audio signal to go below 0 volts, so go negative and positive, like 1.5 volts. And the potentiometer I was using, the digital potentiometer, and I think most of them are not very happy with dealing with input signals that are below ground. Because it's a digital part, I guess. So there might be digital potentiometers that I could have replaced this one with, that would be okay. But the problem was the upswing was fine, but when it was going below ground, it was distorting the signal horrendously because it was very unhappy with the negative swing of the signal. So that's the reason why this potentiometer was bad. And I was trying to still DC block, but then the DC block after the digital potentiometer. I was trying to fix that, but the potentiometer was still inducing some distortion. Yeah, I did not finish completely debugging it and figuring out what is wrong with it, because we just decided to completely abandon that idea and go with a different amplifier. So that's the story with the digital pot. I'm pretty sure should be a solution for this to you, but there are specific digital potentiometers for audio applications. I've seen those, but they are usually super expensive, or much more expensive than a generic digital potentiometer. That was the reason why I used this one, because this one was just a jelly bean random dual potentiometer that I could use. And it turns out there is a reason why there are ones for audio. That's what I understand. Which one did I use? Let's look it up. We can open the design files. Files are on. Okay, let's switch to the desktop. Not iStorm, it's 1bitc, 1up. Git, there we go. Actually, let's open KiCad. KiCad, come on KiCad, come to me. File, open recent, no. 1up. This is the audio repair board. Let's do this. I don't know where it is. Projects 1bitc 1up hardware version 0. This project and the 1up keycap. No, this is wrong. I wanted the schematic. There. So this is this. Oh, let's see if that works. It's still I'm using already the nightly build of KiCad. So yeah, it is the MCP 4661-103E/ML. That's the pot that I was using. So if you see, I did the DC block before, and then went into the digital potentiometer, and then I went into the TPA 61352A2 for the headphone amp. There is a sister amplifier for the speakers from TI. That was the plan, to down the road add mono speaker to it. But this amplifier is so this is the old circuit that we abandoned, and if I open project, let's go to the version 0.2 that has the new schematic. So the new amplifier is a PAM 8019, and this has dual speaker output and the headphone out. So that should be an improved situation. The biggest issue that I need to work on is actually the microphone, because I want to include a microphone on it. Yeah, there's still some more work to be done, and it's completely not laid out. But we are moving forward on the hardware a little bit, which is good, but I have to find some more time on working on this. All right, so that's the 1UP. Any more questions? Oh, Daniel Egger is saying I might want to contact Mario from Gekologic. Okay, let's go on his website. Oh, this guy, the guy who is making this awesome granular sampler. Yeah, that is awesome. I've seen that float through the Boltport Club Slack channel, and that's a good pointer. Yeah, we have currently 2 people that are involved in doing audio and synthesizer stuff. So Bob is totally into that, and then James Hagerman is also into it. So they are definitely interested in this. At the moment, we have to get the drivers a little bit more polished for the audio stuff, and work on the next revision of the hardware, so that we have some hardware to send to folks and play around with. Okay, yeah, that's pretty much it. If you have any more questions, just send me a message either on in the comments of YouTube, or send me a message on the chat here, on the Gitter chat. And yeah, that would be it for today. I will see what I will do next. I definitely need some more connectors to finish this up and send it out to guys. I have a fix for this board, so this board will get a dual row connector. So that's good that I tested this out. I need to put some more bit streams onto the FPGA to test this out. And I think the next stream will be on a different topic. We probably should go back to one of the other projects, like for example the SIGROC related hardware. We will see. Just leave me in the comments some suggestions what we should work on next. Anyways, I want to thank everyone who is supporting these streams. Thanks for my Patreon supporters, especially I wanted to shout out to Kate Temkin, Keen Mazels, Bob Miller, and Garrett Kelly that are donating $5 or more. That's awesome. Thank you so much, guys. This is making it much easier for me to find the time and fund some of these projects that that are not directly financed by 1BitSquared. So I really appreciate that. And if you have a few dollars spared, then I would appreciate if you could donate something to support. But if not, it's all free, and I'm very happy to see you here in the chat and interact with you guys and give suggestions back and forth. This is very useful. Yeah, so as always, if you have been, thank you for watching.